Hello students, today's lecture is about one Neumann architecture. Learning objectives. Understand the origin of one Neumann architecture. Understand one Neumann architecture. Next, understand its components and functionalities. Next, to be aware of other architectures. Next, what is an architecture? To complex or carefully designed structure of something. Next, one Neumann architecture. Input device. Next, central processing unit. Next, control unit. Arithmetic logic unit, registers, and memory unit, and last one, output device. One Neumann architecture. The basic concept behind the von Neumann architecture is ability to store program instructions in memory along with the data on which these instructions operate. Next, the von Neumann architecture describes a general framework or structure that a computer's hardware, programming, and data should follow. Next, even all the most modern computers and mobile devices are designed based on the fundamental concepts. Next, it had three basic components: input and output interfaces, CPU, and memory. Buses carries the data around. Input and output interfaces. The input and output interfaces allow the computer's memory to receive information and send data to output devices. Next, allow the computer to communicate to the user and secondary storage devices like disk and type drivers. Next, central processing unit can be considered the heart of the computing system, including three main components: control unit, arithmetic logic unit, registers. Next, control unit, responsible for decoding the instruction and controlling how data moves around the computer system. Next, the execution of each instruction is determined by a sequence of control signals produced by the control unit. Next, arithmetic logic unit carries out the calculations and logical decisions required by the program instructions. Next, the inputs to an ALU are the data to be operated on called operands and a code indicating the operation to be performed, and the ALU's output is the result of the performed operation. Next, registers are memory location with a specific purpose. Accumulator stores the result of calculation made by the ALU. Program counter keeps track of the location for the next instructions to be dealt with. The program counter then passes the next address to the memory address register. Memory address register stores memory location for data or instruction that needs to be fetched from memory or stored into memory. Memory data register stores data or instructions fetched from memory or any data that it is to be transformed and stored in memory. Current instructional register stores the most recently fetched instructions while it is waiting to be decoded and executed. Next, memory. The computer's memory is used to store program instructions and data. Consists of many memory cells of a fixed size. Each cell has an address associated with it. Two of the commonly used type of memories are RAM and secondary memory. Next, alternative architectures. There are hardware architectures. Memory for data was separated from the memory for instructions. Two memories with two buses allow parallel access to data and instructions. Execution can be twice faster. But control unit for two buses is more complicated and more expensive. There we have finished our lecture. Thank you.